assume that tomorrow is your DSP exam and you don't know anything about decimation and frequency. So I'm going to teach you how to study this topic for your tomorrow's exam. That is through very simple steps. We are going to understand this topic. We are going to learn how to draw the butterfly diagram and how to do the problems on this topic. So by the end of this video, you will be understanding this topic very thoroughly. Okay. Now, let us think that your input sequence, that is in question, it is given that x of n is your input sequence and it is like this, a comma b. So now from this input, that is set a, b, your input is having a length of 2, that is 0 and 1, right? So this is the time positions or your length equal to 2. Now this is a 2-length input sequence, and for this, how can you draw the DIF FFT butterfly? So let's see. So I'm going to draw a butterfly, that is I'm going to teach you how to draw a butterfly. So this is not a very beautiful butterfly, or it is not having so much of aesthetic beauty, but just it is like a elementary class butterfly. So how to draw this butterfly? It is very simple. Draw 2 parallel lines. Now draw 2 diagonals. Okay, this is how your butterfly will generally look. Now there are 2 parallel lines, there are 2 diagonals, and there are 4, generally we say that there are 4 branches for this butterfly, 2 parallel ones and 2 diagonal ones. Okay, so this is how the basic butterfly of a DIF will look. Now for each of these branches, I said there are 4 branches. This is one, these 2 are the other 2. Now there are branch weights for these butterflies, 1, 1, 1, and for the lower one it is -1. Okay, now you are going to apply the input on this side and you will be getting the output on this side. So your inputs are A and B from your x of n, which is set a comma b. Okay, now in the lower parallel branch, that is this one, there is a weight, that is in general Wn raised to k. So if you take this Wn raised to k, that is this Wn raised to k, here the n is the number of inputs and k is the number of butterflies, and k starts from 0. So this thing you have to keep in mind. Okay, so here Wn raised to k is called the twiddle factor. So if you don't know anything about twiddle factor, just assume it as Wn raised to k. Now you have to know the expansion for doing this. What is Wn raised to k? Okay, so if you want to know what is a twiddle factor, just watch the video on either DFT matrix or DFT as a linear transformation. On any of these videos, I have explained how to expand this twiddle factor. Okay, so in this twiddle factor, there is a n, which is a number of inputs, and there is a k, which is a number of butterflies. Okay, so this much you have to know. Now, let's talk about the Wn raised to k for this particular case. Okay, so I told the n is the number of inputs. How many inputs are there? There are 2 inputs, that is the length is 2, and there are 2 inputs and n is equal to 2. Okay, so this butterfly is having 2 inputs, right? So your n is changed as 2. Now k is the number of butterflies and it is starting from 0. So here there is only a single butterfly, so the value of k here is nothing but 0. So W2 raised to 0 is the value here. So your butterfly and the branch weights and everything is completed. Let's talk about the output side. So here for the upper branch, the output is A and this one is B coming right from here. So here the output is A plus B. So this is your upper branch output, and for the lower branch, the A is coming here, A, now minus B, and there is a twiddle factor, right? So A minus B into this twiddle factor. Since the 12 factor is on the output side, you have to multiply it with the a minus b, and it is outside the bracket. So here it is a minus b into w 2 raised to 0, and for the upper branch the output is a plus b. So this is a very basic butterfly for a 2-length input. For discussing about the 4-length input and the 8-length input, we have to understand another thing, that is bit reversal. So we are going to discuss about bit reversal. Now why this is important, you will find out later. So first I am going to talk about the bit reversal of 2-bit. That is, the bits are 0, 0, 0, 1, 1, 0 and 1, 1. Now I am going to perform the bit reversal of these 2-length bits. Okay, so how this bit reversal is done is by exchanging the bits. So for this case there are only 2 bits. So how we will do is, we will exchange the position of these 2 bits. So this 0 will come here, this 0 will come here. So anyways it is both 0, so there is no change in the output of the bit reversed one. So for this case, that is for 1, remove this. What you have to do is, you have to exchange the position of these 2 bits, and it will be like 1, 0. And for this case, if you exchange the positions, it will be like 0 will come here, 1 will come here. Again, for this 1, 1, even if we change the positions, there is no change in the bits or the value. So here it was 0, 0, 0, 1, 1, 0 and 1, 1. That is 0, 1, 2 and 3. And if the bit reversed or bit reversal is performed, the values will be, here it is 0, here it is 1, 0 is 2, here it is 1, here it is 3. So if you bit reverse the two length bits, that is 0, 0, 0, 1, 1, 0 and 1, 1 up to 3, and if you bit reverse it, the result will be like 0, 2, 1 and 3. I am going to perform bit reversal of sequences or inputs with the length of bits equal to 3. That is 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0. This is a binary representation of numbers from 0, 1, 2, 3, etc. up to 7. 1, 0, 0. 1, 0, 1, 1, 1, 0 and 1, 1, 1. That is 0, 1, 2, 3, 4, 5, 6 and 7. Now I am going to perform bit reversal of this. Okay. And how it is performed, that is, here there are 3 bits, right? So I am going to exchange or change the position of the extreme n bits. That is, this 0 will come here and this 0 will go here. So it is like 0, 0 and 0 again, since all zeros. Now let us talk about the second one. I'm going to remove this. The 1 will come here and the 0 will go here. So it will be like 1, 0 and 0. I think it is really clear. Okay, if it is not clear, just consider this case. So here the 0 on the extreme end will come here and this 0 on this side will go here. Here again there is no change since the both ends is having zeros. I hope the board is seen till the last bit. Okay, so why this is important is because you will let to know later in this video. Now we are going to draw the butterfly diagram of decimation and frequency for a length equal to 4 input sequence. That is, I'm going to take a sequence x of n as set A, B, C and D. Okay, and I'm going to draw the butterfly diagram. Okay, so let's see. So earlier for a 2 input sequence, I've drawn first 2 parallel lines, right? So for this case, that is, this length is 4. So I have to draw 4 parallel lines here, 2, 3 and 4. Okay, and on this end, what I'm going to do is I'm going to apply my input A, B, C and D. These are my inputs. Now there are 4 lines, right? I'm going to just draw a dotted line in between the 2 lines, and I'm going to consider these as a pair and this is another pair. Now I'm going to draw the butterfly diagram for a 4 input sequence, that is 4 length input sequence. So this consists of this, for this particular sequence, that is for a 4 length sequence, it consists of 2 stages. Here there is a first stage and here I'm going to draw my second stage. And on the second stage, at that end, I'm going to get my final output. For the first stage, how it is drawn, I'm going to draw. Okay, so here you have to draw a diagonal from the C, this parallel line. So here I've given my input C. So from here, you have to draw a parallel line to the extreme end, that is to A. Sorry, a diagonal you have to draw from C to A. From D to B you have to draw another diagonal. Okay. Now from A to C you have to draw a diagonal, and from B to D you have to draw another diagonal. Okay. So here there are total 2 butterflies, right? This one is one butterfly and this one is another butterfly. So there are 2 crosses, right? So this one is one and this one is another one. So we consider that this consists of how many butterflies? There is 2 butterflies. Right. Okay. So there are how many parallel lines there? There are 1, 2, 3 and 4 parallel lines here. And how many diagonal lines? 1, 2, 3 and 4. And it makes together, all together, how many butterflies? 2 butterflies. Okay. So here I've made a division by drawing a dotted line, right? So the parallel lines below this dotted line will be having a branch weight of -1. -1 here and -1 here. That is, this lower branch and this lower branch is having branch weight of -1. Also, they are having 12 factors. That is, the 12 factors are having a general form of Wn raised to k, right? So here n is A, B, C and D will form. How many inputs are there? 4 inputs, right? So it is n is 4 here. And how many butterflies are there? 2 butterflies. And k value is starting from 0, right? So W4 raised to 0 and W4 raised to 1. So there are 2 butterflies and k value starts from 0, means the k varies from 0 to 1. And n value is the number of inputs. Here there are 4 inputs and hence the n value is 4. So here it is W4 raised to 0 for this lower end, and for this value it is W4 raised to 1. Right, this much is the basic things for the stage 1. I hope it is clear. So there are 2 butterflies and there are 2, that is, we have made a pair of 2, that is A and B, C and D, and we have drawn diagonals from C to A and then D to B, and this diagonal from A to C. We have drawn here from C to A, right? So there is in return from A to C, and for this D to B, there is a return from B to D, and the end weight is W4 raised to 0, W4 raised to 1. That are the 2 twiddle factors. And how will be the output here? So here it will be like this, that is A, then C. So here it is A plus C, here it is B, and the other one is coming from D, right? So it is B plus D, right? So here one value is coming from A and there another one is C, and here is there is a negative here, so it is A minus C. Again, if you look, there is a 12 factor, so W4 raised to 0. The next one is B, and here the other input is coming from D. There is a negative and there is a 12 factor, so B minus D. The minus is because the branch here is negative. So the lower 2 branches are negative. and there is a twiddle factor which is W4 raised to 1. So this forms the stage 1. I'm going to draw the stage 2. And for stage 2, what I'm going to do is, there are two butterflies, one here and one here. So once you're familiar with how to draw the butterflies, simply you have to cross the lines to form the butterflies. Okay, so this is your first butterfly, this is your second butterfly. Now, similar to this one is the basic butterfly which we have discussed earlier. Okay, so we have know the lower branches is having weight of -1. So we have already discussed how to take the output of 2-point sequence using a basic butterfly, right? So this is a basic butterfly number 1. This is the basic butterfly number 2. So there is a lower branch with a weight of -1. Here also -1. So there is a twiddle factor here. You know the inputs is 2. So W2, and there is only one butterfly, right? So W2 raised to 0. Here also it is W2 raised to 0, right? So let us take that the outputs coming on this side is P, Q, R and S. That is the value of this equal to. For the sake of simplicity, I have taken it as P, Q, R and S. And what is the output here? Here it is. For the upper branch it is P plus Q. For the lower branch it is P minus Q into W2 raised to 0. And here it is R plus S, and for the lower one it is R minus S into W2 raised to 0. Okay, so this is how the butterfly diagram of a 4-length input sequence will look like while you are calculating the decimation in frequency FFT. Okay, so this is your stage 2, right? Okay, so we have to take into consideration another thing, that is the order of your input and order of your output. So we have here just taken A, B, C, D like that. Okay, so I'm going to consider the order of my sequence here. So let us take the first value as 0, 0, 0, 1, 1, 0 and 1, 1. That is, my inputs are in the order 0, 1, 2 and 3. So this is the order of my inputs and I have given it in the correct order. Just see it 0, 1, 2 and 3. So that is here 0, 1, 2 and 3. So this is the order of my input. That is, A have a position of 0, B have a position of 1, C have a position of 2, D have a position of 3. These are the time positions 0, 1, 2 and 3, right? So how will your output come like? So the output will be in the order 0, 2, 1 and 3. And here just writing the order of my output, not my output values, but the order of the output values. So if you give the inputs in the correct order, that is, you are directly giving the inputs in as a order 0, 1, 2, 3, that is A, B, C, D, directly in the correct order to the decimation frequency algorithm diagram, but your output will be in the bit reversed order, that is 0, 2, 1 and 3. So if you remember, if you just seek back to the previous position of the video, you can understand that it is nothing but the bit reversed version of this. Next, I'm going to draw the butterfly diagram for a length equal to 8 input sequence. I'm going to consider that my x of n is set x of 0, x of 1, x of 2, x of 3, x of 4, x of 5, x of 6, then x of 7. So this 0, 1, 2, 3, etc. it represents nothing but the time positions of my inputs. Okay, x of 0, that is my first input, second input, third input, like that. So this is a length equal to 8 input sequence. Now I'm going to draw the butterfly diagram for decimation and frequency FFT, that is DIF FFT. So let's see. So for the earlier cases, that is for a length equal to 2 input and length equal to 4 input, we have first drawn, for the 2 input case, we have drawn 2 parallel lines. For the length equal to 4 input case, we have drawn 4 parallel lines. So for the length equal to 8, what we will do? We will draw 8 parallel lines. 1, 2, 3, 4, 5, 6, 7. We'll draw one above 8. Alright. So 1, 2, 3, 4, 5, 6, 7 and 8. What I'm going to do is, first I'm going to take a pair of 4, 4 each. 1, 2, 3, 4 is my first pair. And the bottom 4, 1 are my second one. Okay. And I'm going to apply my inputs in the correct order. That is x of 0, x of 1, x of 2, x of 3, x of 4, x of 5, x of 6 and x of 7. Okay, my lower 4 parallel branches are having weightage of -1, -1, -1 and -1. Now I have to form butterflies by drawing diagonals. First I am going to draw a diagonal from this. So if you are drawing this dotted line, it is very easy to draw the butterfly diagram. So first you have to draw a diagonal from this line, which is just below the dotted line, to the extreme end one, and in return from this one to here. Next, from here to the x of 1, that is from x of 5 to x of 1, and in return from x of 1 to x of 5. Again, from x of 6 to x of 2, from x of 2 to x of 6. Again, from x of 7 to x of 3, from x of 3 to x of 7. So this is your stage 1 of your butterfly diagram. Now something is missing, right? So what is missing here? Nothing but the twiddle factors are missing. So how many inputs are there for this stage? There are 8 inputs, right? So your n value is 8. And how many butterflies are there? Let's count. 1, 2, 3 and 4 butterflies. And your k values is nothing but the number of butterflies, and it starts from 0. So k will vary from 0 to 3. Right, I'm going to write the twiddle factors now. W8 raised to 0, W8 raised to 1, W8 raised to 2 and W8 raised to 3. This is the basic structure of your stage 1 for your length equal to L equal to 8 length sequence. Okay, now how will be your output? This is your x of 0, which is your first output for this branch, first input for this branch, and the second input is coming from, let's look the diagonal, from where it is coming, from x of 4, right? So x of 0 plus x of 4. Here it is x of 1, next one is coming from x of 5, so x of 5. So this is very simple if you just follow the diagonals, the branch weights and everything. So next one is, here it is x of 2 plus the second one is coming from x of 6. This is x of 3. Second one is coming from x of 7, right? So x of 7. So this is your 4 upper outputs for the stage 1. Next is, let's talk about the 4 outputs on the lower branches. The first input is coming from x of 0, and the second one is coming from, that is here, x of 0 minus x of 4 into W8 raised to 0. Here it is x of 1 minus x of 5 into W8 raised to 0. So if you have any problem in finding from where it is the that is where the inputs is coming, just look on the upper outputs. It will be nothing but a negative and multiplied with a twiddle factor. So here it is W8 raised to 1, right? So for the for the third one, it will be x of 2 minus x of 6 into W8 raised to 2. Second, the next one, that is x of 3 minus, here it is x of 7, right? So minus x of 7 into W8 raised to 3. So this is the stage 1 for your length equal to 8 input butterflies. In the stage 2, what we are going to do is, we are going to split this. So this is having a length of 8. So we are going to split it as 4, 4, and we are going to make 2 other butterfly diagrams in the stage 2. And each of those will be having length equal to 4. So this will be one part and this will be other part. Okay, so let's take the outputs will be A, B, C, D, E, F, G and H. Okay, so these are the, I'm just assuming that the results are A, B, C, D, E, F, G, H. So this A, B, C, D will go to this portion and E, F, G, H will come to this portion. And here we are going to draw a butterfly diagram with length of input equal to 4. So which we have already discussed earlier. So I'm just drawing it for you to understand. So this is a 4 length input sequence, and I'm going to draw the butterfly diagram for 4 length input sequence here. We have already discussed about it. The lower branches are -1 and -1. The twiddle factors are W4 raised to 0 and W4 raised to 1. And the outputs are A plus C here, B plus D here. Here it is A minus C into W4 raised to 0, and here it is here it is B minus D into W4 raised to 1. And here also, similar to this, there is another diagram here, and the 2 diagrams forms your stage 2. Now there is another stage here where we are going to split these butterfly diagrams again as 2, 2 each. This is your last stage. Okay, so this figure looks really crowded, right? So what I'll do I'll just remove this, and in order to make it really clear, I'll just write it as A, B, C, D, F, G, H. 2. Okay, so I'm going to write the outputs as A, B, C, D, E, F, G and H. So here your A, B, C, D will come, and your E, F, G and H will come here. So similar to this, there is another diagram here, and it will look like this. The lower branches are negative. Okay, we have already discussed it, right? So it is W4 raised to 0 and W4 raised to 1. Right. So this is your stage 2. The stage 3, you are going to split this stage 2 as again 2, 2 each. That is, first we have taken a 4 length input sequence. We have calculated the output for the stage 1. We are going to apply it into 2 4 length input butterfly diagrams. Then we are going to take the outputs. Then we are going to apply it into the 2 length input butterfly diagram. How to calculate the outputs for stage 2, that is this one and this one, that is your stage 2, and for the stage 3, which is the 2 length input butterflies. So we have already discussed how to calculate the outputs. So what you need to do is, first you have to calculate the outputs for your length equal to 8 input butterfly diagram. Then just give it to the next stage. That is, first calculate the outputs for stage 1, give it to stage 2, then calculate the outputs of stage 2, give it to stage 3, and at the end of the stage 3 you will be getting your final output. But there's again one thing, that you have given the inputs in the correct order, but the outputs you will be obtaining in the bit reversed order. Here, if you see, I have given us x of 0, x of 1, x of 2, x of 3, x of 4, x of 5, x of 6 and x of 7, which is in the correct order. But the outputs will be in the order x of 0, x of 4, x of 2, x of 6, x of 1, x of 5, x of 3 and x of 7. So this is the order of the output, that is the bit reversed order of your input. So in 99% of your DSP exams, till length 8 is asked. So this is how you have to draw the stages of the butterfly, and this is how you have to calculate the output, and this is how your input will flow and your output is obtained. Okay, so another major advantage of studying this butterfly diagram is that most of the mark weightage is given to how you draw the butterfly diagram rather than your final result. So it is really beneficial to if you attempt this question, because if you know how to draw the basic butterfly diagram for 8 input sequence or for a 4 input sequence, you will be getting more than half of the marks. That is a very good thing, right? So whether you know how to calculate the output, whether you know how to find the final result, you have to draw the butterfly diagram, because it is given a lot of weightage while coming to marks. Okay, so this is how you have to draw it, and I'm sure you have understood how to draw the butterfly diagram and how to calculate the result and how the result is being calculated. Okay, so if you enjoyed watching the video, please do share this video with your friends and family, and also do subscribe to the channel. Thank you.